So let's look at this first example. We're going to do 3 problems like this. This is taking off from what we did yesterday that I know a lot of students struggle with. Again, cell phones are away right now, earbuds are off. So we want to take this quadratic function and we're going to rewrite it in vertex form. Please put a little arrow above the 3. Please put a little arrow above the 3. When, please listen, when this number is anything other than a positive 1, we need to rewrite this by factoring out that value. So the very first thing I'm going to do is I'm going to think of this as a y, and I'm going to take this constant and move it to the opposite side. When it moves to the opposite side, in this case, I am subtracting it. Now, I'm going to factor out this value that I've identified. In this case, it is 3. So when I factor out the 3, I'm left with x squared minus 4x, and I'm going to leave this blank spot. I need to figure out what value goes in here. So if I only look at this trinomial, I am going to identify the b value, and that includes the sign in front of it. For this problem, it's -4. I'm always going to divide it by 2 and square it. And that value goes into this missing place. -4 divided by 2 is -2, and -2 squared, -2 times -2, is a +4. This will always be positive. Now, I did not just add 4 to the side. To the right-hand side, I added a value of 12. So on the left-hand side, please add 12 to keep the left and the right sides balanced. 12 and -7 is a +5. Now, I could have you come off to the side and factor this portion right here, but a quick way to do that, to factor it, is to come back to this position, and after you simplify this, including the symbol, don't worry about the square, -4 divided by 2 is -2. That value goes behind the x, and now as I rewrite this in vertex form, I'm going to take the +5, moving it across, the equal sign makes it a -5, and this original problem was g of x. These two equations are equivalent, standard form and vertex form. Okay, here's your next problem. Example number 2, we're going to do the exact same concept. I'm going to start by putting a little arrow above that negative sign as a reminder. Think of this as a y, and I'm going to move the constant to the opposite side by subtracting. Now, on the right-hand side, I'm going to factor out a -1. Anything other than +1 has to be factored out when we are placing it back into vertex form. So I have x squared minus 10x plus some value. Now, I need to make sure this works. Let's check real quick. That's negative x squared, that's a positive 10x, looks great. Now I'm only going to focus on the b value and the sign in front of it to figure out what value goes into this missing place. So I'm going to take -10 divided by 2 and square it. -10 divided by 2 is -5, and -5 squared is 25. I did not add 25 to the right, I added a value of -25. So to keep it balanced, where the left side equals the right side, I need to attach a -25 to the left. On the right-hand side, now I'm able to take this portion, and I could come off to the side, and I could factor it. What multiplies to give us -25 combines to give us -10, but there's a shortcut. The shortcut is whatever this value is inside goes in back of the x. All right, on the left-hand side, I have a -28 when I combine, and now as I rewrite this as the function h of x, I have -1 times quantity x minus 5 squared. Bringing the -25 over to the right means I need to add it. Can I have a 1 through 5 on your level of understanding of this problem? I know it's difficult. Okay? Those that are in my classroom doing live instruction with me may already be done with this. If you are watching this in a directed study position, please press pause, try this one on your own, and then we'll come back and do it together. All right, I'm putting an arrow above the 4 as a reminder. Again, my goal right now is to rewrite this in vertex form. I'm adding opposite 11 to the opposite side, and then I need to factor out anything other than anything other than +1 as a leading coefficient I have to factor out. So I need to factor out this 4. 4 times 1x squared, 4 times 2x. And I want to make sure I did this correctly. And now I'm going to focus in on that b value, taking that value, dividing it by 2, and then squaring it. 2 divided by 2 is 1, 1 squared is 1. Now what is the shortcut? I'm able to take this portion and quickly factor it with the shortcut. Forget about the square, Positive 2 divided by 2 is positive 1. And lastly, as I move the 11 back over to the side and recognize this was function f of x, I have 4 times the quantity x plus 1 quantity squared minus 11. This is factored form. This is standard form. They are equal. Oh my goodness. Good thing we have you guys in class. 4 times 1 is 4. I added 4 here. I need to add 4 over here, which is 15. And then subtract 15. Ah, we got it. Thank you, Fabian. Sorry for those that are watching this. Luckily, they caught my quick mistake here. We're going to go on to the... When we look at the standard form of a quadratic equation, standard form of quadratic equation, ax squared plus bx plus c. This is your leading coefficient. If a is greater than 0, so it's a positive value, what do we know about the shape of the parabola? Yes, it opens up. If a is less than 0, so it's a negative value, it opens down. Okay, you ready? So if a is greater than 0, we would say that a, the leading coefficient, make sure you're listening. If a is greater than, are you ready? Okay, stop bugging him. If a is greater than 0, we would say a is a positive leading coefficient. Now listen closely. When you have a positive leading coefficient, you have this shape, just like Jose shared with us. Okay, and this shape creates an absolute, you probably want to write this down, or global minimum. With quadratic functions, there's going to be an absolute, or sometimes they may be called a global, maximum or minimum. And if they ask you just for the value, not for the coordinates, it's always the y value. So it's y equals some value. Now, if a is less than 0, that means the leading coefficient is negative, then we're going to have, in this position, an absolute or global maximum. And if they asked you for that maximum value, it's going to be the y value of the vertex. We are going to take this basic quadratic function and we're going to analyze it without a calculator in multiple ways. So the first thing that we are going to do is we're going to determine, does this function open up or down? And this function, because the leading coefficient is a hidden 1, well, the a value is greater than 0. So since it's a positive value, I know that this function opens upwards. The next thing we're going to do is we're going to identify the vertex in the easiest way possible, and we're going to identify the equation of the axis of symmetry. Okay, so how do I figure out the vertex? Yes, I could put it in vertex form, but that seems like a little lengthy process to do this. So what I'm going to do is I'm just going to use this formula. And this formula is x equals negative b over 2a. Now in this problem, a is 1, b is negative 7, and c is 12. So I'm going to come down here. X equals negative b over 2a. My b is a negative 7, my a is a 1. Two negatives make a positive. Two negatives make a positive, excuse me. So I'm left with positive 7 over 2, or 3.5, however you want to write it. Positive 7 over 2 over 3.5. Now a vertex is a point on the graph that is either the lowest point or the highest point, depending on our a value for a quadratic function. In this case, it would be the lowest point, and it is a coordinate, so it's an xy. This is the x part, so I have 3.5, or I could write 7.5, but now I need to figure out the y. Now, because we have a decimal, I'm going to grab a calculator. I'll make sure that for your future problems that we do not have decimals. So what I would do next is I'd come up here, taking this x value and plugging it back in. So if I come over here, I have 1 times 3.5 squared minus 7 times 3.5 plus 12. This is going to be the y value, so it's a negative 1/4, negative 1/4, negative 0.25. This is the vertex. Now, how does that relate? If this is the vertex, if I'm making this up, if this is the vertex, the axis of symmetry always cuts straight through it. And with quadratic functions, it's going to cut through the x-axis. So the equation of the axis of symmetry is x equals whatever the x value is every single time for quadratic functions. So I've identified this as going up. I've identified the equation of the axis of symmetry and the vertex. All right. Now the next question is please write down this word. This is a textbook word, and this textbook word wants us to identify. Did you use that word before in freshman year, sophomore year? This wants us to identify what are the local or relative maximums and what are the absolute or global maximums. And I've already shared with you that with quadratic functions, we are only going to have a picture that looks like this or a parabola that opens down. So there's only going to be one low point or one high point. There's no relatives. There's no additional terms here that create extra high points that would be relative, or we could call them local maximums. There's only going to be an absolute maximum or an absolute minimum. In this case, what do we have for this graph? Is it an absolute maximum or a minimum based on the A value? It's going to be a minimum, right? It's going to be a minimum. So I'm going to write down the word minimum. And we can say the word absolute in front of it, or you may want to use the word global, but I want you to recognize those. And they're asking for the Y value, so negative 0.25. Now myself, I'm just going to draw a picture of this. I'm going to go over 3 and down a little bit, and it's going up. Okay, I've got that. It looks something like this. Totally a rough draft. Now my next question after that is, what is the domain? The domain is going to be, there's no restrictions how far it goes to the left as it goes up, and there's no restrictions how far it goes to the right. The range, this goes down as far as negative 0.25, and there's no restrictions how high it goes. And lastly, this goes back all the way back to first semester, is increasing and decreasing intervals. Remember, they are always parentheses. From left to right, we're describing this in terms of x values. It is going down from left to right. So this part is going down. It comes from the far left, and it continues to go down until it gets to an x value of 3.5. At 3.5, it's neither decreasing or increasing. It's just stable at this point. And then after it leaves 3.5 and it moves to the right, it is going up. The second example from this set. Does a parabola, those in front of me are going to answer, does a parabola go up or open down? Okay, so just make yourself a little done. Now we're going to work with the vertex. X equals negative b over 2a. So I'm going to rewrite it, putting parentheses in place of the b and a. My b is a 10, my a is a negative 1. When I simplify this, I get x equals negative 10 over negative 2, so x is equal to positive 5. So for the vertex, remember I need to have an ordered pair. My x is 5. Now how do I figure out the y? I come back up here and I need to do the math. Here's where a lot of people make mistakes. You ready? Mental math. I'm timing you. You have 30 seconds. And then when you get it done, check with your partner. Go ahead. Plug in 5 and get an answer. Where do I anticipate a lot of mistakes to be made? At this very first part. I would assume a lot of students would have taken negative 5 and squared negative 5 to get a positive 25. When we follow the order of operation rules, it says first do the exponents and we multiply afterwards. So 28, that is going to be the other point. I'm going to do a really rough graph here. So here is 5 and 28 is way up here, and we know it goes down, like as simple as that. What is the equation of the axis of symmetry? And I'm going to be, or the line of symmetry, that's another way to say it, and that is going to be this line right here. It's always x equals for quadratic functions, and it's always going to relate back to the x value of the vertex every single time for quadratic functions. All right, does this point have a maximum or minimum? It has a maximum, so we're going to say the absolute maximum, and they're asking for the y value. Is y equals 28. With your partner on paper, because the details matter whether you're using parentheses or you're using brackets, I want you to do domain, range, increasing or decreasing. I want you to do it in 40 seconds or less. Ready? Begin. All right, back here with me. And so the domain, you're going to notice that unless we're talking about like the context of a problem that restricts the domain, our domain for quadratic functions is going to be negative infinity to positive y. There's no limit how far it goes to the left or to the right as it moves down. Now the range, we always go from the lowest up to the highest. There's no limit how low it goes. It goes up as high as a y value of 28, and there's actually a point at 28 for y. That's why we need to include the brackets. Let's do increasing or decreasing. Remember, we're going to start with parentheses right away. Every single time, increasing, decreasing, constants, always going to be parentheses. Okay, this portion right here from left to right is going up. This portion is going up. So it comes from the far left, and it continues to increase until it gets to an x value of 5. Always x values as we described increasing, decreasing, and constant. Now this portion right here, after it leaves an x value of 5, it decreases as it moves to the right. As it moves to the right, it decreases. Okay, so we want to figure out what is the solution set for this inequality. So it is a quadratic inequality. So the first thing I see is I don't like that we have a negative sign here. So watch what I'm going to do. I'm going to divide the entire left side by -1, and I'm going to divide the entire right side by -1. Who remembers what do we do when we divide by negative? Right, we flip the inequality symbol. 0 divided by negative is still 0. And now every one of these needs to be impacted by dividing by -1. So -1 divided by -1 is a positive divided by negative is a negative, and likewise a negative. Some of you can just do this in your head. That's awesome. I'm going to come off to the side. I'm going to see, can I factor this? What multiplies to give you -6 and combines to give you a -1? 3 and 2, and the larger one needs to be negative. Okay, so I'm going to come over here, and I have x minus 3 and x plus 2. All of that is good. I'm going to set each one of these equal to 0, and I'm going to solve. And then I'm going to go to my number line, and on my number line, I'm going to identify 3, and I'm going to identify -2. So here's 0, 1, 2, 3, and 1, 2. Okay, I come back up here. Does everybody see how there's a line underneath? Bless you, Jordan. This line underneath means we need to include in our solution set these 2 points. Now I need to decide, am I going to shade in between them or on the outsides? I'm going to choose, because 0 is, I think, the easiest number to plug in. I'm going to plug in 0, and I'm going to do some mental math here. So I'm testing all the values that are between -2 to 3. I'm going to try 0. 0 minus 3 is -3. 0 plus 2 is 2, and I want to know, is this a true statement? -3 times 2 is -6. Is -6 less than or equal to 0? It is. That means I shade in between. Now you could go ahead and you could test a number to the right of 3 and a number to the left of 2, and it wouldn't work. And I can show you that really quick. If I tested 4, 4 minus 3 is 1, 4 plus 2 is 6, and 6 is less than or equal to 0. That's not a true statement. That's why I do not shade to the right. The same concept would be to the left. Oh, I like this, right? This demonstrates for me. If they want you to put it in interval form, watch this really quickly. I will need everybody looking up here. Am I including the -2 and the 3 for this particular problem? The solution set, I need to include the -2 and go all the way to 3 and include it. This is the solution set represented differently, okay? I would like you now to try this problem. I'm going to press pause. I'm going to test 0. 0 minus 3 is -3. 0 minus 4 is -4. And when I multiply, I get 12. Is 12 less than 0? 12 is not less than 0. I'm not shading here. I'm shading in between because it's every other. And you could test 5. You could do that 5 or 6, whatever. Anything to the right of 4 does not work. Now, here we go. You ready? How do I represent the solution set? Is it parentheses or brackets? Ooh, which one is it? Parentheses, because I'm not including it based on the inequality symbol. Okay? For this video, this is the last set of problems that we're going to go through, and in here we want to find the average rate of change of the function for the given interval. Average rate of change. We're used to hearing the words average rate of change, and we're used to associating it with this. And we think of slope, right? It's the rate of change over a specific interval. So how is this going to work? Please write this down. I'm still doing a rise over a run. I'm still doing rise over a run. I'm going to go through this much slower right now. This is not an ordered pair. This is not x, y. This is your first x and this is your second x. It's the beginning and the end of the interval. So what I'm going to do in just this space right here is I'm going to identify what is x sub 2. X sub 2 is 4. Does everybody see that? And now I'm going to take 4 and I'm going to plug it into the function to get an output. And that's what y is. It's an output. Some of you can just do that in your head right now. But I'm going to come over here and I'm going to do that right now. So I'm going to plug in 4. So negative 3 times 4 plus 1. That's this portion right here. And now I'm going to subtract. I'm going to use the function again that's provided, and I want to identify x sub 1. Well, that's negative 2. And I'm going to plug it in to this function. So negative 3 times negative 2 plus 1. And then I'm going to divide that by x sub 2 subtract x sub 1. So 4 subtract a negative 2. And now I'm going to do the algebra. Okay, you ready? So I have negative 12 plus 1. Okay, that's going to be negative 11. And then I have 6 plus 1. That's going to be 7. And 2 negatives make a positive. That's 4 plus 2 is 6. So right now I have negative 18 over 6. And this gives me a negative 3. This gives me a negative 3. Let's make sense of that. Is everybody ready? Let's make sense of that. I want to quickly graph this, and let's see if I happen to have a board here I can do that on. Because this is such a simple function, I want to graph this, and you're welcome just to watch. I'm going to start right now at positive 1. And I'm going to go down 3 and right 1. Down 3, right 1. So 1, 2, 3 over 1. 1, 2, 3 over 1. And then, you know by now I'm not very neat. 1, 2, 3. So my graph is looking something like this if I'm trying to do it pretty accurately. My graph is looking something like this. Let me pull this back here. Now for this problem it says that we want to figure out what is the average rate of change from negative 2 to positive 4, showing the math. So here's negative 2 all the way up here, and here's positive 4, and positive 4 is here, right here. And so we want to know on this interval, so this area right here, on average, how fast is it rising or is it falling? And this states the answer mathematically is negative 3. On average, it goes down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1. That is true. This is the math we want to see. But if you understand linear functions, you can see that the slope is negative 3. It's the same answer. Does everybody see that? It's the exact same answer. But it's not always going to be that way if we're working with different functions. So how are we going to go about doing this? The exact same way we set it up before. So I'm going to write this down right away. This is my first x and my second x, and it's just like what we learned back in 8th grade, or some of you in freshman year. Rise over run. So g x sub 2 minus g x sub 1 divided by x sub 2 minus x sub 1. We are working with a quadratic function instead of a linear function right now. So I'm going to identify x sub 2, that's 4, and I'm going to plug 4 in here. Now, I'm going to be lazy right now. You guys are pretty bright. If I plug in 4, 4 minus 2 is 2, and 2 squared is 4. That's this part right here. Now I'm going to subtract, and I'm going to identify x sub 1. Okay, that's 1. And I'm going to do the same thing. I'm going to plug it into the function g. 1 minus 2 is negative 1, and negative 1 squared is 1. Okay? On the bottom, I have x sub 2. Okay, that's 4. Subtract x sub 1, that's 1. So 4 minus 1 is 3. 4 minus 1 is 3. This means if we graph this between 1 and 4, including those points, the average rate of change between those points is 1. It's going up at a rate of 1 over 1. Now